Alright, today we're going to look at the cell's use of energy, its storage of energy, and its production of energy. But before we can do that, we have to figure out how to identify what energy actually is to the cell. And what energy is to the cell is a little different than what you might think. A lot of people think that sugar is where we get our energy from. And while it is a primary source of our energy, it is not the primary source of energy for our cells. So on the cellular level, something called ATP is actually the molecule that our cells use as our fuel source or our currency. ATP stands for adenosine triphosphate. Tri, the prefix tri means 3, and it represents the 3 different phosphate groups that are located in ATP. Now, when we look at this molecule, as when we look at any macromolecule that we've considered up to this point, if you think about monosaccharides and how they compare to polysaccharides, we often refer to as polysaccharide as a complex carbohydrate or one that contains more long-term energy storage. And the reason that it contains more long-term energy storage is because the energy that is actually stored within that molecule is stored in the bonds between the atoms. And so this is the same concept in ATP. In ATP, the energy is stored in the bonds that hold the phosphate groups together. So when one phosphate group is removed and this bond is broken, it's this broken bond that provides the energy for the cell. When this happens, the ATP actually goes to what we refer to as ADP, because now instead of adenosine triphosphate, we now have adenosine diphosphate. So in essence, what has happened is this one bond that held the second phosphate group to the third phosphate group has been broken. And when that bond is broken, energy is released. That energy then can be captured by the cell and used for its processes. This reaction is called an exergonic reaction. It's called an exergonic reaction because energy is actually exiting or leaving the product itself. And so we can take ATP as the reactant, break off a phosphate group, and end up with ADP plus energy. And because it's plus energy, it's called an exergonic reaction. Now, if we were to take this phosphate group and rejoin it to the ADP, we would then have ATP. And that would be called an endergonic reaction. And the reason is because the energy, the stored energy, is actually going into the new, bigger molecule. So really, if I were to ask you a question like, which molecule contains more energy, ADP or ATP, you would be wise to answer ATP. And the reason that ATP has more energy than ADP is because ATP has more bonds, and it's the bonds which store the energy.